at Leadpages. I work mostly in the data and integrations department, working with a lot of our third-party services and a lot of our in-house analytics that we run. First off, I want to give a shout out to Demaree. Originally we were supposed to co-present here, but there was a conflict. Nonetheless, he helped me out quite a bit with this presentation, both in creating the slide deck and a lot of the content that we do as well. So I want to make sure that he gets a shout out here. So I mentioned we work at Leadpages, and a little bit about Leadpages. We're a SaaS company located just a few blocks away from here in downtown Minneapolis. We have a suite of online tools that allow easy lead generation, or it allows it to make your lead generation efforts easier for your marketing campaigns, whether it be through gathering emails for your list or helping along your conversions. We run on Append and Compute Engine with the Cloud Data Store as our backend. We're a Python stack, which mostly Python and JavaScript, but we may be expanding to a couple other technologies pretty soon. And Leadpages really is a fantastic company, but we do have one problem. And the problem isn't necessarily bad. It's just we are actually growing too fast to keep up with our own data needs. We have, when we started way back in January of 2013, all the way back then, we were asking pretty simple questions. Mostly questions like, how many page views are we getting on a blog post? Or how many times is a person just visiting our application in general? And at the time, these were okay questions to ask, partially because they are really small questions, they're fairly easy to answer, and they aren't very expensive, either financially or resource-wise, to figure out how to answer them. But as we grew, we ended up wanting to ask larger questions, more complex questions. For instance, what effect does a red background actually have on how far the viewer scrolls down the page if the page is in the real estate industry, when the page in question has more than 16 characters in the heading, does not contain a picture, and the average load time is less than 800 milliseconds, and if the page lists properties in Kansas City, Missouri. Now obviously, that's a bit of a complicated question to answer. It takes quite a few resources to actually parse through all of that information to come to an answer. Normally, if you had this information stored in this MySQL or Postgres database, there would be a lot of work that went into getting enough information to answer this, both in the amount of time that it takes to query for the rows, and once you do, you're going to have a mess of joins, and even then, you're still going to have a lot of processing afterwards to try to actually come to an answer that you can use, or come to a data set that you can use to get to that answer. So to add to the other problem with these kinds of questions is we don't want them to be expensive to answer. And we don't also really, as we're growing, we don't necessarily want to deal with all of the data store sharding and the running of instances and the peaks and the valleys of how our traffic goes along in the information. And we also don't want it to take that much time to figure this out. We've got a lot of questions. We want them all answered pretty quickly. We don't want to spend a whole bunch of time writing up MapReduces to try to figure out these questions. So is that really too much to ask? In most cases, yes, it is. But then adding to a lot of the things that we like is BigQuery. It was mentioned earlier in the keynote speech, because it does provide a fast way for you to get to these answers. BigQuery is actually, the very basic concepts of the data processing that goes into BigQuery actually dates all the way back to architectural designs that are from 1995. Google developed MapReduce that is very closely based on those architectural designs. MapReduce essentially goes through and allows batch data processing, but Google wanted something that was faster and easier to do ad hoc queries and off-the-cuff questions. They wanted something more flexible, which led to Dremel. Dremel started in about 2004 at Google. At first it didn't actually involve parallel processing to make it faster. It was actually just a way to sift through large amounts of data. As time went on, they continued to add more features like parallelism, and then they put it out under a different name, BigQuery, in May of 2010. In order to access BigQuery, you do have to have a premium Google Cloud Services account, and you have to have the right subscription to access it. It's normally accessed via the REST API or the console client, even though the query syntax is very SQL-like. You provide JSON. Most of the libraries actually wrap this around, so you end up only dealing with the SQL-like query. But you do have an access token, and at its base, it is a JSON REST API. So your managers are going to want to know some things. How much does BigQuery cost? The good news is that bulk importing and exporting of data is actually free. They don't charge you for any of that. No matter how much you're going to put in or pull out at a time, it doesn't matter. All I know on the resource limits for that is that it can't be more than 100,000 rows a second for bulk imports. Table copies and reads are also free. So if you want to copy data from one table to another to sift it down to an answer, it doesn't cost you anything. The things that cost you money, like mentioned earlier in the keynote, are storage, which is 2 cents per gigabyte per month of persistent data in the data store. And then streaming inserts, because of the bandwidth involved, also cost money, but it's actually quite small. It's 1 cent per 100,000 rows that you stream inward. Querying is a little bit complicated to explain, in my opinion. Google allows you to have 1 terabyte free per month of returned result data. So if you send a query, the result of that query that gets sent back to you, there's a maximum limit of 64 megabytes for that query. That data that gets sent back to you applies towards your 1 terabyte a month free. If you end up getting more than a terabyte in result data back per month, then it's $5 per terabyte per month, which is still not that expensive considering in order to start paying money, you'll have to use 2 terabytes, or you'll have to use more than 1 terabyte, and up to 2 terabytes is only $5. So BigQuery at Leadpages has provided a very valuable tool for us, whether it be in our business analytics for generating reports for our executives or our finance team, making marketing decisions, or even powering user-facing analytics in some cases. It just saves us a lot of time in actually developing these features for the users, and actually it saves us time in trying to figure out an easy way to provide our own information. So I know nobody likes buzzwords, and they're kind of just out there and they're annoying, but really what we're talking about in BigQuery is big data. We have to be honest here. And the question is, how much is big data? I know talking to a whole bunch of people, most computers that you buy without any sort of upgrades, just any generic computer like one that I have here, comes with 500 gigabytes of disk storage. That doesn't even come remotely close. I'm talking more about Library of Congress textual database is 20 terabytes. Amazon inventory and customer data, not even transactions or financial data having to do with any of that, is 42 terabytes alone. YouTube is 100 plus terabytes of user data that doesn't even count most videos that's uploaded per second. Google's search engine alone is 850 plus terabytes and growing a crazy ton by the second. And the World Data Center for Climate, which is historical meteorological data, is 6.2 petabytes, and of course, still growing faster than we can even imagine. So, when you're looking at big data, you realize it's actually really hard to sift through all of that data to get to an answer, whether it be for the weather. What are the historical highs and lows for the past 100 years? That's a lot of information that we have. So normal SQL databases aren't exactly great at handling those sizes of a query, but the syntax is nice. So in BigQuery, like I mentioned before, it's a very SQL-like query that you send to the BigQuery server over its REST API. They expanded a little bit to work with big data and actually provide you with a couple other functions, actually quite a few functions, to process data while you're querying. So this query is actually accessing a public archive that GitHub puts out, which is basically a massive event data store of all actions that happen in GitHub. They publish this just because they don't want to be the only ones to figure out how people are using GitHub. They want everybody else to be able to figure it out too, and to find out how to use big data searches. So if you're not familiar here, the max repository forks, that gets an aggregate value of the maximum value within the scope of that column. So of all the events, it will find the maximum repository forks for a given repository URL. And group by rows, BigQuery, which is different from any normal SQL database, BigQuery you have to group. If you want to do any sort of processing on them, you normally have to group by any non-aggregated value, and you cannot group by any aggregated value. In this instance, you see group each by. Each allows you to process larger data sets. It is not extremely performant, but it's required for data sets that have a large number of distinct values. So if you have a whole bunch of unique values that are expected in a specific field, you're going to want to use the each, whether it be group by or order by. So now let's go to an example of a more complex query that is actually from the healthcare industry. The healthcare industry has a lot of data. It's estimated that last year there was 72 exabytes of data total in the entire industry. That is such an insane amount of data that you wouldn't even, it's hard to imagine how somebody would come to an answer from any of that information, even though it's distributed across many servers, and you have the power of many servers trying to figure this out. It's still a large problem. This specific query is finding the cigarette use of people in the United States in the year 2003 relative to their weight, their sex, the state that they lived in, and the average of their parents' age. This pretty complicated query only took 1.3 seconds and processed only 5 gigabytes worth of data, but that's pretty quick for 5 gigabytes. And it returned a query result of 23 kilobytes, which is 10 values and 192 rows worth of data from millions of rows. This is a simpler example of what you saw a more complex one this morning. That BigQuery supports nested queries, and it actually does nested queries very quickly. This one is getting the respective word count from a whole bunch of selections of Shakespeare's writings. It took less than a second for almost 4 gigabytes of data, and it returned 382 bytes, and that's about 20 rows of data for the 2 columns. Again, that's parsing through almost 1 million rows, not quite. So this one's getting pretty specific. You want a lot of information that is due to one specific location on the planet. When you're looking at data points that are returned from whether it be where a location is for your Uber car, or where the closest ice cream shop is, you're actually trying to figure out where that is based on your location. BigQuery can help you parse through the data and find the closest value. So here gives you a rectangular area around San Francisco Bay Area. It's a very simple example, but it shows that you can do the calculations needed in one. This took almost 4 seconds, processed nearly 100 gigabytes of data, and returned for a result of 15 kilobytes, which is only a few rows. So a couple things about BigQuery also are getting specific, unique results are not as intuitive as they may seem. And some queries that you're familiar with from SQL aren't always, they aren't how you're used to them. For example, you cannot do a select distinct query to get distinct values from a row. However, you can do a count distinct. You can count the distinct ones, but you can't actually select and query for them from BigQuery alone. Documentation doesn't exactly explain why that is, but that's just the way it is right now. BigQuery is not intended for persistence of your application data in terms of using it as a backend how you would a NoSQL database or a MySQL database. The reason being you can't update. It's an append-only data store. The good news about the append-only data store is that it's pretty cheap to do things, both from a financial standpoint in BigQuery and from a resource perspective. You need to know what's free and what's not. And usually, inserting things are less free. They take a lot more resources due to the fact that the database is actually built for taking information out of it, not necessarily making it easy to put things in. So what exactly is append-only? Sort of touched on this, but you may write only to the end of a table, new information, but you cannot edit existing data that is already in that table. So there's bad news and good news to that. The bad news is, if you find there's a mistake that is in dire need that you need to edit the table, you literally have to drop the entire table and import again. Which isn't that big of a deal considering it is free to import the data, but that's just a time constraint. And again, the good news is it's pretty cheap to do everything that you need to fix your issues. In reality, at Leadpages, we have a batch operation that runs on a consistent time basis that puts the information from the Google App Engine data store into BigQuery so that we can use it and more easily query through it instead of having to try to get great results from the Google Data Store engine in their query process. But if you're not using App Engine, the good news is that it's still pretty easy to put information into BigQuery. They allow you to import data through CSV and JSON. It's pretty straightforward how to do that. However, the documentation, it can be found in preparing data for BigQuery at cloud.google.com/BigQuery. Importing JSON files is actually kind of interesting in BigQuery. In a columnar format, the way that BigQuery is, you might imagine that it tries to flatten it somehow. That's not actually always the case. For instance, if you were inserting this JSON object into a table that is called people, you have a person with their name, you have the date that they were born, and their sex. The name would go in just as a flat string, and so would the sex. However, the date would go in as an object, how you might think of an object in an object-oriented format. You can query for the date through the dot object syntax that you find in many of your object-oriented languages. So if you were to query for date.month from the people table, you would actually be able to match it to the month. So in real world, we've got a couple examples from the healthcare industry, the location industry. But how can we actually use this to answer our question? So to recap, what effect does a red button have on how far the viewer scrolls down the page if the page is in the real estate industry when the page in question has more than 16 characters in the heading, does not contain a picture, the average page load time is less than 800 milliseconds, and if the page lists properties on the Missouri side of Kansas City? That is all you need in the query. So in here, you see how I mentioned before with the dot object format here. We're actually querying and pulling out page.background color, and just to save space in typing later, you save it as a variable background color so I can use it elsewhere in the query. We find the average length of user scroll, the average load time from Leadpages .page views. You find the industry of the page that the page view was on. You get the length of the heading and make sure that it is larger than 16 characters, that the picture does not have an image, that the average load time is less than 800 milliseconds, and that the body of the page contains Kansas City and Missouri, using the lower syntax, using the lower functions so that we make sure that everything in there is lowercase just to make it easier for us. However, we could do a regular expression check too, which doesn't actually take much more time. In here, we don't expect to have a lot of distinct values, so the group by does not require the each, and in fact, for performance, we don't want that there. We're going to order by the user scroll and the background color, and limit by 500. So if you also want to add another constraint, it's pretty easy. I only want the pages that were created in 2014. The year allows you to take a Unix timestamp and return the year that that timestamp was in. You can have it equal a year, and then you'll get that question, or you'll get your answer there. So that query essentially would return the color of the background, the percentage that the user scrolled, and the page load time in milliseconds, ordered by the percentage that that user scrolled. So essentially what we're doing here is we're sorting by conversion rate, because we're figuring out the highest percentage per background color. So if 50% of if people who have visited a page with a red background color in the real estate industry, following all those constraints, scrolled down halfway through the page, but people with a blue background only scrolled down a quarter of the page, you're probably going to want to go with the red background. However, how would you know that if you didn't have this data? more generic uses, just like we do at Leadpages. We could use it for information for creating reports that are in revenue trends for finance, or for just how your users use the product that you have. The data may vary month to month, but you can also get more granular, time-based, and detailed queries. So if a person, you only want to count the users that are from the United States or even from Minnesota, and you want to make sure that those are also users that signed up from January 1st to January 3rd, the beginning of the year. Basically, any sort of aggregate value that you might want to find. There are also user-facing needs for this. You can create user-facing analytics and statistics for how their visitors to their product end up using the product, and user-facing analytics for their time series. But again, don't use it to actually hold the information for your application. It will not go well. BigQuery is meant to add to and allow you to easily query for information. It's not actually meant to support to be the main database for the back. So it's very powerful. It allows for mathematics to be done right in the query so that you're actually parsing through and finding values instead of having to do that at a separate time. It allows you to come up with aggregate values in real time and ad hoc querying. Importing data isn't always trivial, and it's usually going to be a repeatable process. Simply because you may have incorrect data in there, you may want to start again. Or you may want to put in log data as it comes in real time, just so that you can query it at any moment. Currently, we use BigQuery for our analysis, but again, not persistence. I've had many conversations. I know I brought this persistence thing up a lot. I've had many conversations with people talking about how they can use BigQuery to actually run their application in terms of storing users in there and updating it, and that's not how it is. And I've seen them come up with some very interesting ways of trying to make BigQuery actually do that. So I've come to the end of my slide deck here. If you would like a copy of this, you can text BigQuery to 33444 for a copy of the slides. It will send you an email with a PDF download. This is courtesy of one of our products, Leadpages, which is for enterprise users. Standard text messaging rates apply. Any questions at all?
I have one. Oh, sorry. Do you have the ability to influence indexing at all with this, or do you take whatever they give you?
No, you do not. Indexing is done in the background, partially because it's based on Dremel. Dremel does real-time indexing, and it caches that result.
Have you ever accidentally done a query and cost like thousands of dollars?
I personally have not. And honestly, I cannot think of a circumstance in which that would happen.
Okay.
Because I seriously tried so hard to try to find one that even got up to the max 64 megabyte result size. I never ever got to it. Because all the questions that you have should be succinct enough that you can actually get the information essentially from one query in BigQuery.
How often, what type of massaging you do to your data, to your transactional data before importing into BigQuery? Like your transactional data model and your BigQuery data, whether it's a CSV or a JSON, might not match always. What type of processing you do, and how long does it take at Leadpages now to load the data into BigQuery?
We essentially take the data as it comes in, and we store it in our persistent data storage. And then we take a batch process that runs, I believe it's hourly, hourly, and then it takes that and puts it up into BigQuery as a bulk upload instead of a streaming insert.
Streaming inserts cost money.
Because yes, the streaming inserts cost money, bulk imports do not.
And you upload it to cloud storage.
Correct.
Can you give the data to Java?